All right. Good afternoon again, guys. So we're just gonna work through the remaining questions that we had from the last class. I think we were at 2014, this paper that is on the screen now. That cave paper 2014. I know a lot of you in advanced, but it doesn't matter. The level of some of the questions are the same in pure math and advanced. So once the level is the same or even just a little bit above, we can do it. Advanced students can do it. And it basically should build the confidence because you see that if you can see and understand and do questions that are on a pure maths paper, then that should give you more confidence about the advanced. All right. It means that pure maths students will be doing questions with the same level that you can do. And so your advanced questions would not be any more difficult than these questions. All right, so this was on 2014, a 2014 paper. And we said we were going to do number 2B, 2C, and D. Right? So this is number 2. This is function, which is no longer on the advanced syllabus, only on the pure maths. But we're going to do this B, this C, and we're going to do this D. All right. So for this one, where we have the E, that's also not an admaths, but it's the exponential constant is similar to pi on a calculator, and it relates to log to base E, which is written ln. So log to base E, which is called the natural log, is written ln. All right. So that's what it is. So this could be done. Any number that was here is so still this is still just a disguised quadratic equation. All right. And E is a constant on the calculator. So if I were to just bring up the calculator and show you what that constant is. Let's see, it's 2 point something. Where is E? So the E is in this line on the calculator. The fourth thing right beside the ln, you see the e to the x. All right, that's what we're talking about. So if we want to know the value of E, we can raise E to the power 1. And that is a 2.71. So it's a constant similar to pi. All right, exponential constant similar to pi. So it's really just a value. That's the value of it, similar to pi. All right, so this question is not really strange, this one right here. All right, so those two and that. All right, so let's get a blank screen here so we can do some work. I want to do questions on 2017 next. But I can see the screen and hear me good, right? Just want to make sure. But I can hear me and see the screen. Hello?
Yes.
Yes, sir.
Okay. All right. B. So this part gives us this thing, it's telling us that this thing is true. It is basically saying that this thing is equal to that. Given that this thing is equal to that, so it means that we're going to have to use this somewhere. We are to show that the log of this is equal to that. All right, that's what we're to show. I think this can be done. This can be done 2 ways. We can start from here and work towards getting that log. That's one way to do it. But maybe the easier way to do it is to start with this and prove that it is equal to that. And at some point, this has to come into play. All right, that must come into play at some point. All right, so I'm just thinking in my head which way might be the easier way. I think the easier way to do it is to start with this expression and show that it is equal to that. All right, using logs. So it is a matter of taking this expression right here, the left side, and making adjustments using the laws of logs. This will come into play at some point, and in the end, it's going to be equal to that thing. All right, so let's approach it that way. So questions like these are centered on your knowledge, on what you know. The more things you know in terms of the laws of logs, the easier these questions are. All right, I'm going to leave this as the screen for the time being. This is going to be used at some point. All right, it's going to be used at some point. This thing. going to be used at some point. But I'm going to start with the left side of this expression and say the left-hand side is equal to 3 log of a plus b over 2. All right, I'm starting there. And I want this now to become this thing. That's what it is. I want it to become that thing. All right. So, all right. So the first thing I'm going to do, I'm going to move this 3 and put it up as a power. That's the first thing I'm going to do. I'm certain that there's not one way to do this thing, but that's what I'm going to do first. I'm going to write that as log of a plus b over 2 all cubed. Then I'm going to apply this cube on the numerator and on the denominator. And so it's going to become the log of a plus b all cubed over 2 cubed. And then now by the laws of logs, I can break this up because the log of a quotient becomes the log of this numerator minus the log of this denominator. Now this denominator is just 8. All right, so we can leave it there. Let's leave it under there. It's 8. I'm going to leave it under there as I 8. All right, but what I need to do is expand this out. Remember now, I'm trying to use this thing. To use that thing, I need to identify this a cube and b cube term. I'll get them when I expand this out. So you would have to know the expansion for the a cube plus b cube. Let me see if we can write it out for you. So it's something that can be worked out. So let's say I don't know what it is I want to work out. Let me work it out on this side. So let's say I want to work out a cube, a plus b all cube, right? Let's say I want to work it out over here. The result for it should be a plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. That's what it is when you expand it. But let me go step by step and show. Let's say you got it and you didn't know that it is equal to this and I want to work it out. You could recognize that a plus b cubed is equal to a plus b squared, which you know to expand, times a plus b. They could expand this in a normal way and write it as a squared plus 2ab plus b squared. You must know that this thing expands out to that. You must know that. All right, so the first term squared, then twice the product of the 2, meaning you multiply the a and the b, and you double it to get the 2ab. And then the second term squared is there. You're multiplying that now by this a plus b. Then it becomes each of these values times these 2 values. So this one first times these 2 values would give me a cubed. I say a times the a is a cubed. And then a times the b becomes a squared b. Then it's time for this middle term times each of these. And so it will be the 2ab times this a, which will become 2a squared b. And then the 2ab times the b will become 2ab squared. It's time for this now. It will be this b squared times this a, which will become a plus ab squared. I just put it in alphabetical order. With b squared times a, it's the same as ab squared. And then the b squared times this b will become b cubed. And then if you consolidate and put the like terms together, this is the only cube term on the a, so it's a cubed. Then you have a squared b, and you have 2a squared b, so you have 3a squared b. So you get plus 3a squared b. Then you have 2ab squared and another ab squared. So those add 3ab squared. And then you have this b cubed plus b cubed. So you see, you're getting about the same thing that I wrote up here. But I prefer to just know stuff. All right, so that's why I could write this out of my head. All right, it's good to know So at CSEC, you know to write out the perfect square, like this one. When you do maths at a higher level, it will be good for you to know the perfect cube, the cube expansion of the cube. Just know it, all right? Because, you know, you do maths at a higher level, so you want to grow, all right? But there's something that we call a binomial expansion that you can use to expand like a plus b to any power n. There's a formal way to do it. That's a topic that used to be in AdMaths years ago, but it's no longer in AdMaths. I think it is in Premath Unit 2, actually. All right, so let's get back to this now. So this numerator here is now equal to this expression that I just showed you, right? And so I'm going to write it up there. So it becomes, expand this, it becomes a cubed. Oh, put in a log first. It becomes a log of, and the numerator now is a cubed plus 3a squared b plus 3ab squared plus b cubed. And dividing all of that by this 2 cubed now, which is 8. All right. And remember now, don't use this thing over here so yet, you know. Don't use that yet. I can take these off, as I just explained. Let's use this to show how we'll get that expression in the bracket there. Expansion of the cube. I'm taking these off now, right? So this thing right here now, remember, the a cubed plus the b cubed plus 3a squared b is equal to 5a b squared. So let's look at it now. So the a cube and the b cube over here will be these two terms plus this 3a squared b. This is 3a squared b. So those three things that I've written is equal to this 5ab squared. That those three things equal 5ab squared. All right, so I'm gonna leave those in red. I'm underline them in red. This, and this equal 5ab squared. I'm gonna write that now. So this becomes equal to the log of those three things that I've underlined is equal to 5ab squared, and I'm adding back this 3ab squared plus 3ab squared all over 8. So these are like terms. 5ab squared and 3ab squared becomes 8ab squared. So it becomes a log of 8ab squared over 8. So those 8s will cancel each other. And so it works out to be the log of ab squared, but the 8s cancel. Then this is really now the log of a product. You want to pull it up now. It becomes a log of a plus the log of b squared. And then now this 2 can come to the front by that law of log. Remember now, we're working towards getting this thing, you know? So it becomes the log of a plus 2 times the log of b, which then is the right hand side. Therefore, show that is it. Personally, like this is nice to redo. Want to go to that?
Yes, sir.
But okay, that is it. Nice and easy. So as I was saying, the possibility exists that we could have worked on this, but let's leave that for another day. All right, so that part has been completed. Let's jump now to D. Let's jump to this one, not D, C. Let's jump to C now, which is to solve these two equations, right? So one is our indices and one is our logs. This one is really this guy's quadratic equation. Let's look at it. All right, so this one right here, it gives us e to the x plus 1 over e to the x minus 2 equals 0. I don't want this. I want to expand it so it's going to become a quadratic. So I'm going to multiply it through by e to the x. I multiply it through by e to the x, and this will become e to the x squared And then I can do this one and it will become minus 2 times e to the x. And then this will become 1 plus 1 equals 0. And so that is your quadratic equation. That's what we have. It is just like y squared minus 2y plus 1 equals 0. If you make the y equal e to the x. Some people make that change now and write it as y, find the y, and then replace the y again with the e to the x. But I don't need to do that. You can just work straight from this, recognize a quadratic and factorize it. And so it will become bracket. Hold on a second, let me take this card. Hold on a second. Kevin? Yeah, man, I'll tell you, I'll finish the thing. Cool. All right, guys, sorry about that. I'm still at work. All right, so the factor of this, as we would do the factor of that, would be e to the x, e to the x. Factor of this 1 is only 1 and 1. This says the two signs in the bracket are the same. They are both negative, negative, negative. We can check if it is correct, but the middle term is negative 2 e to the x. So the far product is minus e to the x, and the near product is minus e to the x. So you add them and get the middle term of minus 2 e to the x. You know that you factorize it properly, right? And so this becomes e to the x is equal to 1 repeated. Why do I say repeated? Because both factors giving us the same thing. All right, so we can term for that is that it is repeated. And so if e to the x is equal to 1, then x is 0, because e raised to any power, e raised to e, any number raised to the power 0 is 1. Or if you wanted, you could take log of both sides, and you'll be taking the log of 1. Log of 1 is 0. So anyway, look at it, this is equal to 0. All right, if you decide that you're going to take log of both sides, remember you're trying to get the x out of the power, take log. I told you that. Because this is really a pure mass paper, and it's e you're working if you really take log to base e, which is ln. So you will do ln of e to the x equals, and you ln the right side as well, ln of 1. But the log of 1 to any base is 0. So this comes to the front, and it becomes x ln e equals the log of 1. ln 1 is 0. And then this now is equal to 1. This thing here is equal to 1. Because it's log to base e of e. ln is log to base e. So you see that x is equal to 0 in truth. So you could know it from right here by knowing that any number raised to the power 0 is 1. So if I'm an indices is 1, it means that the power is 0. And this, that is it, our index is 1, and the power is 0. So the answer here is 0. But I go to that, x is 0. But I go to that.
Yes,
Hello. This one now, logs. All right, so that's a logs equation I want to solve. Remember, when solving a logs equation like this, you want to reduce this whole log equation to one of two ways. I don't want to reduce it to the form. I'm writing it out here for you. I want to reduce it to the form, the log of a number equals the log of another number, which this would mean that the n is equal to the m. And you would solve this the other way, or you want to reduce it to the log of a number to a base is equal to some power. And if that is the case, this would mean that this number n is equal to this base raised to that power p. You just have to know it. So you want to bring this equation to either this format, so you can get to this and solve this. You want to bring it to this format, so you can get to that and solve that. Now, based on the fact that this has a 2 on the right side, looks to me that I want to be working with the second way. So I want to leave this side, consolidate this side as a log expression, and put it equal to a power that 2. So I want to be using this approach. I'm going to be using this approach for this question. All right, so let's go. So the left-hand side right here, I'm going to write it out. Log to base 2, x plus 1, minus log to base 2 of 3x plus 1 is equal to 2. When you divide logs with the same base, it becomes the log of the quotient at that same base. So this side becomes the log to base 2 of x plus 1 divided by 3x plus 1. And that is all equal to 2. So it's now in this format right here. This is your n. This is your base raised to that power. All right. So this number n, which is x plus 1 over 3x plus 1, is going to be equal to this base raised to that power 2. Plus 2 squared it becomes. This 2 squared is actually a 4. Tell me that this thing is equal to 4. So solving for x, we're going to take this denominator and multiply it across by 4. We're going to get x plus 1 equals the 4 times this 3x is 12x. And then the 4 times this 1 is plus 4. And then what happens next? What happens next? All right, so this 12 comes over here and subtract. Or you can take this one over there and subtract. All right, let's say we take this 4 and bring it over this side and subtract from the 1. It becomes negative 3. And take this 1x and bring it over there and subtract from the 12x, I get 11x. I take this 11 and divide under here. And so the x then becomes negative 3 over 11. All right, so x equals negative 3 over 11. Now, logs is a peculiar function. And we cannot find the log of a negative number. So you get a value like this, for example, with your x. You want to check and see if it would leave the expression in here, for example, positive. You don't want in here to become negative, and you don't want it to become 0. You cannot find the log of 0 either. So you must always do that check, right? No, it's not a problem with this question because this is negative 3 over 11. When I add it to the 1, I'm still going to have a positive number. What about this one? When I multiply this by the 3, it becomes negative 3 over 11. No, negative 9 over 11 plus 1. This is going to be positive as well. So this will also be positive. So the answer is valid. The answer over here is valid. So I don't need to change it because if the x was a value that's going to cause anything in here, cause inside here, it will become negative or 0 and cause there to be negative or 0, then I could not accept that answer. It would be inadmissible. All right? Because you cannot find the log of 0 and cannot find the log of a negative number. They don't exist. That is it. So far, so good, guys? So far, so good?
Yes, sir.
All right. Remember, I want to send the video, you redo the questions. All right? Now, this question now wants us to, without using a calculator, show that this plus that plus that plus that all add to 10. What it is that multiple ways to do this. You can decide to add these two and add these two. And that by adding them, the denominator will automatically be rationalized because to add these two, I mean the two denominators the same, I will have to multiply this denominator up here and down here. And that will create the difference of 2 squares in the denominator, which will rationalize these surds. And then I do the same thing with these two. And those two, again, this denominator multiply up here and down here, and vice versa. And will cause us to have rational numbers in the denominator. So I can approach this by adding these two and adding these two, and then add up the result, and it should all be 10. Let's use that way. Another way you could have done it would be to rationalize this denominator and this expression, rationalize that one, rationalize each of them, and get a 10. But because I see that if you add these two, the denominator becomes rational, because you end up having to multiply these two, which becomes the difference of two squares in the surd, and so it must work out to be a rational number. All right? So let's do it that way. We're going to add these two, and then add these two. And what we can do is call the sum of these two A, call the sum of these two B, and then the final result will be A plus B. All right? So I'm going to do it that way. So I'm going to say A equals, I'm adding these two now. So A equals root 3 minus 1 over root 3 plus 1 plus, I'm spacing it out, so I have space to multiply. Root 3 plus 1 over root 3 minus 1. So to add these two, I need to make the two denominators become the same. So I need to multiply this denominator up here and down there, and I need to multiply this denominator up here and down here. Let's work on rationalize each denominator. That's what is going to become the end result anyway. You know? So I'm going to multiply this first fraction by root 3 minus 1 over root 3 minus 1. I multiply this second one by root 3 plus 1 over root 3 plus 1. So you see the two denominators will become the same. So the numerator becomes the perfect square of root 3 plus minus 1, and the perfect square of root 3 plus 1. All right, that's what we end up getting. So it becomes equal to root 3 minus 1 squared plus this one now is root 3 plus 1 squared all over root 3 minus 1 times root 3 plus 1. Plus this times this becomes that on both fractions. I add the two numerators. All right, and so I'm going to add this one. So you square this first, it becomes a 3. You're doing twice the product of a 2, so you get minus 2 root 3. You square this negative 1, it becomes a positive 1. Then doing the same thing with this now. Square this root 3, it becomes 3. They multiply these two things and double it, it becomes 2 root 3. And the second term squared is a plus 1 all over. And this demonstrates the difference of two squares. It becomes root 3 squared, which is 3, minus 1 squared, which is 1. All right, let's put two lines. Root 3 squared minus 1 squared, difference of 2 squared. Let's consolidate now. All right, so this is 3 and 3 makes 6, 7 and 8. That is 8. So it's 8. And then this minus root 3 and this positive root 3 cancel each other. So let's have 8 over. This becomes a 3 minus 1, which is 2. And 8 divided by 2 is 4. So this works out to be 4. All right? So we have the A part of it. I'm going to do the B part the same way basically. What's the and? The B part of it is almost the same thing we're doing. So we can even just copy these down and change the 3 to 2 in these expressions. Change the 3 to 2. It's kind of short the time. Copy. For the B, we just have 2 instead of 3. All right, so all these 3's become 2, 2, 2, 2, 2, 2, 2, 2, 2. We'll do ones first. 2, 2, 2, 2, 2, 2, 2, 2, 2. But understand that? Basically doing the same thing, but it's just that we are root 2 now. Very good?
Yes, sir.
Yes, sir.
Yes, sir.
Good. So the numerator here becomes this thing is a square, root 2 minus 1 squared plus, this is now root 2 plus 1, root 2 plus 1 squared over becomes this times that, which is root 2 minus 1 times root 2 plus 1.
Oh,
So,
I was until it stopped working. Can you relax?
Mr. Mike,
Sure.
Mr. Mike, when I expand this now, root 2 squared is 2, then twice product of a 2 here becomes minus 2 root 2, then this root 2 squared is plus 2, and then twice product of this 2 are left out with plus 1. So let's go again. So the first term squared, that root 2 squared is 2. Then twice product of a 2, multiply these two things and double it, I get minus 2 root 2. And the second term squared is a 1. And this one now over here. So this root 2 squared is 2. Then twice product of 2 is plus 2 root 2. And the second term squared is 1. And dividing all of that by this thing now, which is the difference of 2 squared. From this squared, root 2 squared minus 1 squared. 1 squared. Consolidate the values now. I get 2 plus 2 is 4. 4. Oh, all right. So 2 plus 2 is 4. And 1 and 1 is 2. So we get 6, right? So this and this make 3. And 2 make 5. And 1 make 6. Say 6 on the numerator. But this negative 2, 2 cancels this positive 2, 2. And divide that now by this. This becomes 2 minus 1. 2 minus 1 is 1. This works out to be 6. So the A is 4 here, and the B is 6. And the result is A plus B must be 10. Therefore, sure. That is it. Are you good at that?
Yes, sir.
That's not only.
Yes, sir.
That's good. All right, beautiful. All right, so that finishes that paper. That finishes that paper. Let's look at the 2017 paper now. I'll give you 2017. 2017 pure maths was the next paper. Let's see. Um, 2018, oh, 2017. This one. I think we can write on the paper for the. All right, and the question I told you to do on this paper was all right, so you're going to 2017 paper first time 2A, 3A, and 3B. All right, let's see. Right. So doing 2A. All right, so see another similar question here. 2A. We just did, just that is no ln to log is 2A. And we're doing this as well as a part of 2A. It's the first question. 2A and 3A. Let's mark them from now. 3A is a 2. Okay. And is a part of 3A. Also doing 3B. 3B. All right, so mark the questions that we're going to be doing Okay, this is prayer math. We're not doing this one yet, all right? Let's go. We're doing the ones that are add maths level in these prayer math papers. All right, let's go. 2A first. So that's similar question to the one we did not so long ago, where they tell us that this thing is equal to that. And we have to prove this. Prove that this works out to be that. All right, so this because I have to generate this A squared plus B squared, right? Now work from this and get it. From this and get it. All right, let's start with this side and working to get that side. I have to be smart, right? We're trying to generate these squares out. Let's look and learn. We want to say the left-hand side is equal. One of the things about logs is always that logs can be done in multiple ways, all right? So maybe I'm going to do it for 2 ways. Let's do it 2 ways. Let's work from this one first. Left-hand side equals right-hand side. So start with left side, I'm trying to get the right side. So pay attention now. Develop some skills. So the left-hand side, as presented, is ln. ln is just log to base e, all right? So don't get scared of it. It's just another log function, similar to log to base 10. So they tell us it is equal to log of a plus b over 4. Now remember, you have to be able to use this. Now these square terms can be generated from the square. What I can do, I can put on a square and half it back here. So I'm going to say that. But I can say that, I put another way. I'm put another way. Let's put another way. Develop the squares, right? So, because I want a square up here, so I know it's a square up here, so I put on it the same. So that, okay, I multiply this by 2 and then half it back. And I take this 2 and put it up here. Right? So this whole expression becomes equal to half of ln a plus b over 4 squared. Are you good with that?
Yes, sir.
Put up here, right? I have to learn to do these things. I'm going to expand this simply because I'm trying to generate these squares, these square terms. So I'm going to become half. So half there already, half is in answer. You know? Right? Half ln, I'm going to expand the numerator now, and it becomes a squared plus 2ab plus b squared divided by, and square this 4, I get 16. What it becomes. Question tells us that a squared plus b squared is 14ab. You see this a squared plus this b squared, they add to 14ab. All right, so this then becomes half ln 14ab plus this 2ab all over 16. Now this 14ab and this 2ab is 16ab. So it becomes half ln 16ab over 16. And the 16s cancel. And so I'm left with half ln plus ab. And ln ab can be split out and put the half outside of one. Splitting this now, it becomes ln a plus ln b, which is the right side. That is it. Half ln a plus ln b. What about that? Are you okay?
Yes, sir.
Sir,
All right. Yes.
can you do the right-hand side first?
You start here, so I reckon was that. All right. So
Yes.
I guess you can, you know, it's easier to go from this to this. But I don't think CXC. I think when they set a proof like this, guys, you really want to go from left to right. You want to go from left to right. But if you're in an exam, you're not seeing how to go from left to right, and you see how to go from right to left, then do it. From right to left. But I really think they want to go this way. You get me? I think they really want to go from left to right. Take the left side and prove till they get the right side. All right? That is it. Let me work it from this. Let me start from here and introduce logs on it. And work until we get this thing over here. Let's look at it. Let's look at it. Let's look at this. We have to start with this expression here and introduce the logs on it. And see if we can actually prove all of that starting from this. That's the approach I'm thinking of using now. All right, let's see. So like I'm trying to get this expression, and then log it out of all of this. That's what it is, All right. So if I have a squared plus b squared, you tell me that a squared plus b squared is equal to 14ab. Now this a squared plus b squared, right? Is the same as a plus b all squared minus 2ab. Just like alpha squared plus beta squared is equal to alpha plus beta all squared minus 2 alpha beta. That's what I'm using right here. Knowledge from that, the same thing. Right? And all of that is equal to 14. Then I'm going to take this and bring it over here. Add to that, I'm going to get 16ab. So it means then a plus b all squared is equal to 16ab. All right. All right. Next thing is that this has a 4 under here. All right. That has a 4 under there. Oh my God, get a 4 under there now. All right. Come and get a 4 under there now. I'm going to divide both sides by 4. No, by 4. 4 squared. 4 squared is 16, right? All right. I'm going to divide both sides by 16. All right. Let's divide both sides by 16. Because I want to get the 4 under there. So divide this side by 16. And divide this side by the same 16. Instead of writing 16, I'm going to write 4 squared. 4. All right, 4 squared. So because this numerator is squared and this denominator is also squared, I can consolidate these and put both under the square. And so I'm going to get a plus b all over 4 squared is now equal to this 16 cancels this 16. And so I'm getting just ab. Gotta go to that.
Yes, sir.
And then now, introduce the ln. I'm going to take the ln of both sides. I can move this 2 here. I'm going to introduce ln on both sides. I'm going to ln this side and ln that side. So let me shift on this a little bit. I'm now taking ln of both sides in red. When I take ln of both sides, this 2 will come to the front. So I'm going to get 2 ln a plus b over 4 equals ln, and then I can expand this because ln of ab becomes ln a plus ln b. So I get ln a plus ln b. All right, ln a plus ln b. Then I need to do to get rid of this 2 now is half the right side. Multiply both sides by a half. When I divide multiply 2 by a half to get rid of this 2, I will get ln a plus b over 4 equals half bracket ln E plus ln B. Shown. I'm showing it to be true. What I did this time, started this thing that I gave me, and then I work towards getting this expression in here first, and then I introduce the ln on both sides. So that's another way it could have been done. This is the OR method right here. That is it. Very good at that.
Yes, sir.
Yes, sir.
All right, 2A. What is the mark? Hold on a second. Hold on a second. Hello? I'm in a class now. Yes? Yes. Yeah. You can borrow some of the 2 kg from upstairs. Yeah. And use it. You're gonna use 2 of the 1 kg, right? And you're gonna use 2 of the 2 kg and 1/800. Yeah, 1/800 of the white. So it's 2 1 kg, 2 2 kg, and 1/8 kg. You hear me say a while ago? 2 1 kg, 2 2 kg, and 1 of the 800. Yes. Yes, yes. All right. So get some of the 2 kg from upstairs. All right. All right, cool. All right, guys. Sorry about that. I'm still at work, I'm still at work. All right. That's why I had the class online today, because I have some stuff to clear up at work to do. So that is it. All right, let's continue. So we're solving this now. This guy is quadratic. All right. And I can tell you something about these things. Do not work with negative powers. Try not to work with negative powers. When you're solving equations like that, don't work with negative powers. That's one of the, that's like a hint I'm giving you. Can do it, but kind of safer not to work with negative powers. When you can avoid working with negative powers, you avoid it. So the first thing I would do is write this expression as 1/2 to the x to begin with. All right, that is what you do. All right, so this thing is going to become, it says your response may be expressed in terms of log. You can leave the answer in terms of log. All right, so I'm going to write this here as 1/2 to the x to begin, plus 3 times 2 to the x. I'm trying to make a quadratic, and so I'm going to take this 4 and bring it on this side. It has -4, so I have my equal 0. All right, so what we're going to do next now, we're going to multiply by 2 by this 2 to the x from a quadratic. That's right. We'll multiply by 2 to the x, and it becomes that it's going to become a quadratic x. So this is really just what we call this guy's quadratic. That's what it is. The quadratic equation that is this guy's. When I multiply this by 2 to the x, I'm going to get 3 times 2 to the x squared. Why did I do that? Because I want my squared term to come first. I multiply this by 2 to the x, I'm going to get -4 times 2 to the x. And then I multiply this by 2 to the x, it just becomes a +1 equals 0. So I now have my quadratic. This is just like 3y red. This is just like 3y squared minus 4y plus 1 equals 0. So some persons would write it like this. Solve for y and then put back y equals 2 to the x and then solve. But to me, that is waste of time. I prefer to just work with this just to see and know that my variable is 2 to the x. All right? So I wanted to practice it that way. That's why you have to improve. I'm going to factorize this as a quadratic. So I will factorize this with y, just I'm going to factorize it with my variable is 2 to the x. So ready. So the factor of this is 3 times 2 to the x times 2 to the x. Factors of 1 is only 1 and 1. This term that the two signs in the bracket are the same, they are both negative. So negative, negative. So you can check it. This is 3 times 2 to the x. That's a minus. And this is minus 1 times 2 to the x. Minus 3 and minus 1 makes minus 4. So in order to factorize good, you can proceed. So then, is that this bracket equal to 0, which would make 2 to the x is the variable in it, so making this a subject. 2 to the x equals 1 over 3, or 2 to the x equals 1. That is it. So now you're solving these two things. Remember, any number raised to the power 0 is 1. So for this one, the is 0, the x is 0. This one, the x is 0. All right, you know that the x is 0. If you didn't know, you could still take log of both sides. You could say the log of 2 to the x equals log of 1. The log of 1 is 0. Right? Log of 1 is 0, and then this x will come to the front. So you get x times the log of 2 equals 0. And you take this log of 2 and divide and get 0, but I don't like to act like we don't know maths. So I prefer to recognize from right here that the x is equal to 0. More things you know, the better. Then to get this x amount of the power, you take logs of both sides. So I'm going to get the log of 2 to the x equals the log of 1 over 3. Remember the question says you can leave your answers as log, right? You have to work out this log of 1 over 3. You can leave it. This x comes to the front. And so it becomes x times the log of 2 equals the log of a third. And you can take this log of 2 and divide it on here. And so the x therefore is the log of a third. The x becomes the log of a third divided by the log of 2. Those are your two answers right here. X equals 0 is an answer. And then we're going to check if it is valid. Let's check if it is valid. Yes, indices we're solving, right? Yes, indices is going to log. It's okay. So this is a valid answer. And this is another answer. That is it. That is it. Those are two answers. Remember, guys, if you didn't get it, want to write them over for me, please. Advanced level work. This is the advanced level work, even though it's on a clear math paper. But I write that. Very good.
Yes, sir.
Let's continue. I think I want another part here. No, didn't. I'll finish this one. Oh, so we're doing 3, right? I think we're doing 3. 2, 8, 2B, and then 3, right? We're doing this 2, 2 to 4. There is an identity that to be an exam paper, you know. Imagine you're asking us to prove it. All right? It should be on a formula sheet. It's here they're asking us to prove it. Let me keep on this formula sheet. Keep for this formula. No, I love the formula sheet. But it's an identity that you're expected to know. Based on this, it looks like you have to be able to prove all the identities. Well, this is experiment. Doesn't matter. I must can prove it after that. They want us to prove that this equals that. How they start? They start with what you know tan is. The left-hand side, let's go. The left-hand side, which is this side, can be written as sine of a plus b over the cos a plus b. Right? That's the first thing. I'm going to expand this and expand that. All right? So the formula must be a half. Let's go. So it becomes equal to, I'm going to expand this now. But the expansion of sine is sine cos, cos sine. Whatever is inside the bracket here, same sign comes out in expanded form, right? So this thing becomes sine cos cos sine, sine cos plus cos sine, A, B, A, B, sine cos cos sine, sine cos cos sine. Expansion of cos, of sine, sorry. Then expansion of cos is cos, cos, sine, sine. If you have a plus here, you're going to get a minus in between. Expansion of this is cos, cos, sine, sine. Cos, cos. This is a plus, I'm going to put a minus in between them. Minus, sine, sine. A, B, A, B. You have to know these things. All right. Then now, let's pick a term. Let's pick a value. Now, this value right here is a 1. In order for this to become that 1, I am going to have to divide it by cos A, cos B. So it tells me that I need to divide each term by cos A, cos B. That's as simple as that, you know. So I need to divide the whole numerator, divide it by cos A, cos B. Divide the numerator by cos A, cos B, and also divide the denominator by cos A, cos B, because that's going to make this become the 1 that I want it, that is in that position. All right, and then it will all work itself out. It will all work out together. So let's go. This becomes equal to. I'm going to divide this first by the cos A, cos B. And right out what I'm going to get. I'm going to get sine A, cos B over this cos A, cos B. Cos A, cos B plus. I'm going to divide this now again by the cos A, cos B. I'm going to get cos A sine B divided by this cos A, cos B, cos A, cos B. That's on the numerator, divided by, divide this now by the cos A, cos B. It's going to become a 1. So just write that out. It's going to become a 1, because that was my target value. Minus, I'm going to divide this now by the cos A, cos B. So I want to have sine A, sine B over the cos A, cos B. All right, let's zoom in on it down a bit. What happens here now is that this is cos B and cos B. They cancel each other. So this gone and that gone. Then this now is cos A and cos A. They cancel each other. Those two gone. And then now, this sine A over cos A becomes a tan A. And then this sine B over sine cos B becomes a tan B. Then down on this expression now, this sine A over cos A becomes a tan A. And this sine B over cos B becomes a tan B. So we're going to end up getting what we want. As I said, this sine A over cos A is tan A plus this sine B over cos B is tan B divided by this 1 minus this sine A over cos A is tan A, and this sine B over cos B is tan B. And that is the right hand side. That is it shown. Or you can see quite easily brushed aside. That's what we used to write when we were in school. Yep. That's it, guys. That's it. Nice and easy. But good at that?
Yes, sir.
Huh?
Yes, sir.
Just like this, you go and practice semester and develop these little things, right? That you do. The expression to get what you want. You look at what you want and you work towards getting it to do what you need to do to get the expression that you want. You know what you're looking toward. All right, so that was 3. All right, so we're going to do this one as well, all right? So we're going to do this one as well. This one says, Sine A is 3/5 over 5. Cos B is -1/2. A is acute, means in the first quadrant, but B is obtuse, means in the second quadrant. All right, that's what I want us to express this in terms of that expression. All right, we're going to expand this into what we just found a while ago up here. If you got to that. And so what it is that we need to find out what tan A is from that and what tan B is from that. Kind of straightforward. All right, so for this one, it's like you have a quadrant diagram like this, and the angle is acute. So your angle is in this quadrant, the triangle is in the first quadrant here. So the x is x, y, and x is positive, everything positive, right? So your triangle is in the first quadrant. So the A is here. And the sine is opposite of hypotenuse. So opposite is 3, hypotenuse is 5. And so this side, the unknown side, is a 4. That becomes a 3, 4, 5 triangle. If you don't know, it will be the square root of hypotenuse squared, 5 squared minus 3 squared. And that will be a 4 to 4. Well, you should know the 3, 4, 5 triangle. So this side is 4. It means then that the tan of A is opposite over adjacent. Tan of A is opposite 3 over 4. 3 over 4. Then now, the obtuse angle now, the B is obtuse. That's why the cos is negative now, because obtuse means that we're in the second quadrant. So, to draw the quadrant diagram, it is like your triangle now is in this second quadrant right here. All right, where the x value is negative and the y value is positive. And in the second quadrant, tan is negative. So let's draw it. So let me undo that. I'm going to draw the triangle to look like this one. As if I'm in the second quadrant, right? So I'm going to draw the triangle like this. And so this is my B. I'm going to put the B here. All right, it's in 90 degrees. It's in 90 degrees. So they said the cos of B is -1/2. So this side is -1. So this is -1 right here. And the hypotenuse is 2. Remember that this is positive because it is vertical, right? It's a positive y value, not vertical, it's positive y value. So to find this side, it's Pythagoras' theorem again, to be the square root of 2 squared minus this side square, which is 1 squared. So to become square root of 4 minus 1, which is square root of 3. So this side is a square root of 3. Using Pythagoras' theorem, this side becomes equal to the square root of 3. Using Pythagoras' theorem. And so based on that, now the tan of B equals opposite over adjacent. It is √3 over -1. So it becomes negative √3. That's the tan of B. All right? Now we're trying to find this value now. So the tan of A plus B we know is the tan of A plus the tan of B all over 1 minus the product tan B. So putting in those values now. The tan of A is this one. 3 over 4, opposite over adjacent, 3 over 4. Plus the tan of B is this one, minus √3. So this whole plus tan B becomes minus √3. So I'm going to put minus √3 right here. Divided by this 1 minus tan A again is this 3 over 4. 3 over 4. Times the tan of B is minus √3. This tan of B is minus √3. So I'm going to put minus √3. And I want to answer in this format, you know. So if we work towards getting that format, right? Pay attention. I want the answer to be in this format. So we're going to have to express that in that format, right? Let's see what we have. So let's kind of simplify everything. I'm going to multiply the numerator by 4 and the denominator by 4 to get rid of these fractions. So multiply the numerator by 4 and multiply the denominator by 4 as well. So the 4 times this means that that's 3. And the 4 times this gives me negative 4 root 3 divided by the 4 times this one is a 4. And then the 4 times this, watch this now. This minus going to make this a plus under here. And then the 4, then the 4 times the 4 is going to cancel this 4. I'm going to be left with 3 root 3. So I'm going to get 3 root 3. But understand that? Understand that, guys?
Yes, sir.
Good. But I don't want this under the denominator, so we need to rationalize this denominator to be able to get an expression like that. We have to rationalize the denominator. So we need to multiply by the conjugate. We want to multiply numerator and denominator by the conjugate of it, which is 4 minus 3 root 3 over 4 minus 3 root 3. So we'll generate the difference of 2 squares on the denominator. All right, let's go now. So the numerator becomes, I'm going to take this 3 and multiply each of those 2 values first. So I'm going to get 3 times this 4 is 12. And the 3 times this becomes minus 9 root 3. Minus 9 root 3. When you use this now, multiply each of these 2 values. So the negative 4 root 3 times this 4 becomes negative 16 root 3. Then the negative 4 root 3 times that negative 3 root 3. The minus first becomes a plus. The 4 times the 3 is at 12. And then the root 3 times root 3 is 3. All over. This times this now the difference of 2 squared. So it becomes this term squared, which is 4 squared, minus this term squared. Let me write it out for you. 3 root 3 squared. Let's go step by step. Let's start to consolidate now. All right. So this right here is 36 plus this is 12. That makes 48. So that's 48. And then this is minus 9 root 3 and minus 16 root 3. 9 and 16 is 25. Minus 25 root 3. The denominator now. This becomes 16 minus. This 3 squared is 9. And this root 3 squared is 3. I'm going step by step for you. And so this under here becomes 16 minus 27. 16 minus 27 is what? Minus 11. So it becomes 48 minus 25 root 3 over negative 11. That's right. Because 11 and 16 is 27. Good. Negative 11. But go to that. But this is 27, you know. And since I want it in this format, we're going to have to divide each of the values by 11. So it's divided by the negative 11, giving negative 48 over 11. Then this divided by the negative 11, the minus makes this a plus 25 over 11, 3. So this is your A, and this is your B. That is what we have right here. Nice question. Very good at that. Let's over again.
Yes, sir.
Very good. All right. So you have a lot of the working going on. It's not difficult stuff, right? You need to practice. Comfortable. All right. Anything else on this question? Yes. We have to solve this guy right here. So you have a sine squared and a cos squared. You only have a cos. Can't change this. So and know that these two go together as this cos squared and that, but I have to change this into cos squared expression. Alright? That's what we have to do for this question. Change this because I have a cos. We change this into cos squared. So this sine square right here is actually 1 minus cos squared. Let's write it out. Let's write it out. Let's write it out. So this sine squared is 1 minus cos squared theta. Then I'm subtracting back. I'm putting back everything here after that. Everything going back. I'm going to get back the minus 2 cos squared theta plus the 3 cos theta plus the 5 equals 0. No, this one 0 to 4 pi. That means that we have to go in the circle twice. All right? 0 to 4 pi. All right. Let's consolidate. This one, this is minus 3 cos squared. Minus 3 cos squared theta. This is a little cos term. I'm going to get plus cos theta. Then this and this give me 6 plus 6 equals 0. I like to work with my square term positive, negative right now. These can all be divided. I make a mistake. It's supposed to be a 3 in front of this. Side 3. Let's go. 3 cos theta. So these two give me this. And then this one is that. And then the 1 and the 5 give me that 6. Good. Each of these can be divided through by 3. But additionally, I want my square term to be positive. And so what we're going to do is divide by negative 3 instead to get the square term positive. I divide through by negative 3. This negative 3 is cancelled. I'm left here with cos squared theta. Divide this by negative 3 is going to change to a minus cos theta. Divide this by negative 3 is going to become a minus 2 equals 0. So that's quadratic in cos, the factorize. Let's go factorize it. Quadratic in cos. It's cos theta. Cos theta. All the factors of 2, 1 and 2. Two signs in the bracket are different. Is the greater product, the minus sign. The greater product is the part product. That's 2 times, this is just 1 time. With the greater product positive, negative like the middle term. So that's part product, that's the negative. They put the minus here and plus there. So I'm getting cos theta equals minus 1 or cos theta equals 2. But this is not valid. Cos cannot be outside negative 1 or positive 1. Right? Cos theta has to be less than or equal to 1, greater than or equal to negative 1. So this is not valid. Same thing for sine. Sine also has to be in that range. It's not going to produce any value. So you're really only solving this one. All right. And it's nice, easy value for getting 1. Cos of 0 is 1. Cos of 0 is 1. But this is negative 1. All right. So we're going to draw a quadrant diagram for this one. Let's proceed the normal way. And we have a value you want where cos is negative. Cos is negative here and there. So there are 2 quadrants that you want. I'm working in radians, right? Yes, radians. I have a pi. We're working in radians. So the alpha that we want, you can read. Alpha, principal acute angle. Alpha, principal acute alpha angle will be cos to the minus 1 of positive of this. We'll put negative together, alpha and the positive. The negative is taken care of by you picking 2 quadrants where cos is negative. The principal acute is cos minus 1 of 1. That is 0. Is equal to 0. Cos of 0 is 1. More things you know, the better. So let's calculator. Remember, this quadrant is pi minus alpha, and this quadrant is pi plus alpha. But alpha is 0. So you don't get in pi. We really want to get in pi, right? We really here in pi. And you're subtracting 0 and you're adding 0. You really want to get in pi. So the theta is equal to pi. The question is they must go all the way around to 4 pi. So that's only 2 quadrants. 2 quadrants giving you pi. So to get, you have to go around the circle another time. So you're going to add 2 pi to this pi. It becomes pi plus 2 pi. Going to circle a second time. This is now 3 pi. You can't go another time, but if you add another 2 pi, you're going to reach 5 pi, which is outside the range. So those are the two answers, pi and 3 pi. So theta equals pi and 3 pi. Those are the two answers right there. Got to go to that.
Yes, sir.
Is it so far? That is it. All right, I think that finished this paper. Yep. The next paper I gave you, I think I gave you an ADMAT paper as well. So look at that one. Right, so I gave you the ADMAT 2012 question 2 and question 4. All right, let's see if we can find that paper now. I'm not seeing it 25. I know it's in here somewhere. Not coming up. It's so far. That is it. So we're doing number 2 and number 4. I'm doing this question right here. Number 2 and I think number 4. I'll do it. 1, 4. Right. All right. So can I write on this? So let's bring up blank. All right. So number 2. Number 2 gives us this simple equation that with alpha and beta, and all I want to do is calculate alpha squared plus beta squared. Easy, easy, easy. So it's x squared minus 4x plus 6 equals 0. This has root alpha and beta. Now look at this equation. This equation is already in the form x squared minus sum times x plus p equals 0. And that the s is already 4. The sum is already 4. The p is already 6. We calculated they are there. The alpha plus beta, which is the sum, is 4. And the alpha beta is 6. If one is a formula, I use minus p over a. It will work out to be minus and negative 4 over 1, which will equal to 4 anyway. And for this one, it will be C over A, and the C will be 6 over 1, which is 6. Once it's in the format, now you can write on the value. All right, you see the value there. More things you know, the better. All right, but that is the question is really asking us now for alpha squared plus beta squared. You must know in terms of the alpha plus beta and alpha beta, this thing is equal to alpha plus beta all squared minus 2 alpha beta. So using these two values down here to get the value. So the alpha plus beta is 4, it's 4 squared minus 2 times the alpha beta is 6. That becomes 16 minus 12. 16 minus 12 is 4. So the answer is 4 for this one. So we got capital T. What good at that? Are
Yes,
okay?
sir.
All right. So this one now is a rational inequality. Easy to turn into a quadratic. So you have 2x minus 5 over 3x plus 1 greater than 0. Multiply both sides by the square of the denominator. So 3x minus 1 squared. On the right side times 3x minus 1 squared. On the left side, on the left side, on the right side. Why do we multiply by the square? To ensure that we multiply with a positive value. And this will cancel the denominator and turn it into a product. This side will remain 0. All right, so it's going to turn out to be a product, which now is 3x plus 1 times 2x minus 5 greater than 0. So that's the factor form of a quadratic. All right, and if you know the factors, you're going to know the roots. So we can sketch it. It's going to be a smile. If we expand it, this time it's going to give you a positive square term. So this inequality is related to a small quadratic function. And that will be the axis. The root from this factor would be 5 over 2. So you put this equal to 0 to be 5 over 2 right here. I'm putting an unshaded circle because there's no equal and not inequality. And from this one to be negative a third right here. Negative a third. And you want a part of graph that's greater than 0 above the x-axis, I should say. So that is up here and up here. These are obtained by values to the right of this 5 over 2 and to the left of this negative a third. So the solution becomes on this side, the x is less than the negative a third. Or on this side, the x will be greater than 5 over 2. So that is your solution right there. But after that, we have used the sketch method. What are good
Yes,
at that?
Yes, sir.
This one now. That's a serious question. APGP. Let's see what it says. It says a customer repays a loan monthly by increasing the payment each month by X dollars. So that's a AP, increasing by a fixed amount. It says if the customer pays $50 in the fifth month, so we're gonna call it the fifth month, the fifth term, So it says that the fifth term, this is the fifth payment, it's $50. Working in dollars, so we're gonna know it's $50. The fifth term is A plus 4D. We're talking about the AP. We recognize the AP is 50. And it is $70 in the ninth month, means that the ninth term, paying each month. The ninth term is $70. The ninth term is A plus 8D, it's $70. And so we have these two simultaneous equations to solve to find the first term and the common difference. solving those two. So we can subtract. This is equation 1, this is equation 2. We're going to subtract. Once you find out the A and D, you can answer anything, you know. First term and the common difference, you can answer anything, you know. We're going to subtract 2 minus 1. 2 minus 1, equation 2, and equation 1. So this A will subtract that A. 8D minus 4D is 4D equals 70 minus 50 is 20. Whereby this 4, the T is equal to 5. So the common difference is $5 that they are paying each month. And then the first term, if you take this 5 and put it up here, for example, you're going to get 20. Right? And then you subtract the 20, you're going to get 30. So the A equals 30. You can say, and the A plus 4 times 5 is equal to 50 in the first equation. This right here says 20. Subtract 20 over there. The A equals 30. So the first term was $30. First payment was $30. And they paid $5 more each month. All right. It says calculate total amount of money we paid at the end of 24 months. So what you want is the sum to 24 months. That's what you want. Sum to 24 months. That's all I want from this question. Total payment of 24 months. All right. You're going to use the sum formula. So now that you know the A and the D, you're good to go. All right. So the sum, 24 months, 24 payments that pay each month is, you know what, 2 into 2A plus n minus 1. I'm writing out the formula for you. D n minus 1D, where the n is 24. So it becomes 24 over 2 into 2 times A. The A is 30 plus the 24 minus 1 here is 23, and the D is 5. And that's what you're working out with the calculator. The answer, I'm going to put a dollar sign on it. That is it. All right, let's work it out. Calculator would be, well, 12 over 2 right here. The 24 over 2 there's 12 into 2 times 30 plus 23 times 5. $2,010. $2,100. $2,100. Gotta go to that. That's a big
Yes, sir.
Is it? What did I do? I think I put the wrong thing. I want this to be the main thing. All right, so that finishes that question there. That was it. $2,100. All right, so we're doing number 4 in this paper as well, right? So that finishes number 2. Well, number 4, then we'll call it a day. I'm gonna send some more work in the group for us to do in the next class, all right? So I'm on the revision over this period. Class. On the revision. All right, so the question gives us this diagram. This is going to be a circular measure for sure. Let's see this sector right here. It says the diagram shows a sector of a circle, center O, center is O, with an adjoining square. So this is a square. And given us this side as 4. So it means then that each side is 4 meters from the right-hand from now. Because it is a square. 4 meters, 4 meters. 4 meters, and all these angles are 90. Everything important. All right. If this is 4, it's a distance from the center to the circumference of that arc over the habit here. This is also 4. The radius of the circle there is also 4. The radius of the sector is 4. Let's see what does it say. It says the angle there is pi by 3. That's on the diagram. Pi by 3, remember, 60 degrees. It says calculate given answer in terms of pi, which means that pi must be in the answer. The area of the shape. I don't want the area of the entire shape. So the shape is a square and a sector. Let's just call it 1 and 2. We have area 1 and area 2. So the area of the shape is equal to area 1 plus area 2. Now area 1 is just a square down here. So it becomes 4 squared. 4 times 4. 4 times 4. 4 squared. Area 2 is a sector. Area of a sector, remember, let's write it out. Area of the sector is half r squared theta, radius squared times the angle. The angle is pi by 3. So this area over here now, using that formula, becomes half. Remember, the radius is 4, so it's 4 squared times theta. The theta is pi by 3. Is it? I believe the answer in terms of the pi. So this is 16. This is 16 plus, what is this now? This is half of 16 is 8, right? This is 16, half of 16, 8. It becomes 8, 5, 5, 3. That is meters squared. It was meters, and so I remember the answer in meters. So that's where. Is it 16 plus 8 pi over 3? What about that? But okay?
Yes, sir.
Yes, sir. All right, next part wants a perimeter of a shape. The perimeter of a shape is the distance around it, right? You cannot choose any part of it along across it. So the perimeter of a shape is this, and this thing that I'm marking out in red. Take this out. Let's mark it out in red. Right, so it is this side here, plus this side here, plus that side there, plus this side up here. So you can't come across this way, and you cannot go across the shape to get the perimeter, plus this arc. So it's kind of easy, but this is 4, this is 4, this is 4, this is 4. So it's 4, 4. What is missing is this arc length. This arc length, which is r times theta, is arc length. And r is 4. Right. This is r theta. R is 4. And theta is pi by 3. This is 4 pi by 3. So we can write it here, part 2. The perimeter of the shape becomes 1, 2, 3, 4. 4 times 4 meters. 4 times 4 meters. Love put the meters. 4 times 4 plus the arc. The arc right here is this 4 pi by 3. 4 pi over 3. That becomes 16 plus 4 pi by 3. And the question says in terms of pi, I believe it's an answer. Perimeter is measured in distance, which is meters. Perimeter is a distance, which is measured in meters. Are you good with that?
Yes, sir.
And that finishes that part. Then we'll come down to this part down here. This part right here. So it's giving us some help. All right. It tells us that the cos of pi by 3 is root 3 over 2, but it's better to know because not every question give you this information. The cos of pi by 3 is a half. the sine of pi by 4 and the cos of pi by 4 is the same, root 2 over 2. All these things you should know. I want us to evaluate this. Remember, I gave you one like this in the class. Now, I promise you that they would not have given you everything. But sometimes when they give you these, they expect to work out the rest. Better to know all of them in your head. Sine, cos, and tan for 30 degrees, 60 degrees, 45 degrees, 90 degrees. This pi by 3 is the 60 degrees. This is pi by 3. This is pi by 6. This is pi by 4. This is pi by 2. You need to know all of those in your head. More things you know, the better. All right? So, we want to work this out now. We want to split up this angle. Let's look at it. One of those common angles. So, you want to work out the cos of 7 pi by 12. Cos 7 pi by 12 is the same as the cos of 3 pi by 12 plus 4 pi by 12. Let's write this pi better. I've broken up the 7 pi by 12 into 3 pi by 12, 4 pi by 12, which then becomes equal to, this becomes pi by 4. That's 3 to 1 time, 3 to 4 times pi by 4. And this becomes pi by 3, 4 to 1 time, 4 to 3 times. So pi by 4 and pi by 3, they become the cos pi by 4 plus pi by 3. And then we need to expand this. Expansion of cos is cos, cos, sine, sine. So it becomes cos pi by 4, cos pi by 3. That's a cos, cos. Instead of a plus, you need a minus out here. So it's minus sine pi by 3, sine, no, pi by 4 first. Doesn't really matter, the same thing because it's sine, sine. Sine pi by 3. Now notice, they gave you the sine of pi by 3 now. But you also need a cos of pi by 3. All right? They didn't give you the cos of pi by, oh, they gave it here. The cos of pi by 3. Oh, they gave you everything. Fortunate. Okay, so there you go. They gave you everything. You're lucky in this one. All right? So it's putting in those values now. So the cos of pi by 4 is root 2 over 2. Cos of pi by 3 is a half. So multiplying these. Minus the sine of pi by 4 is root 2 over 2. And the sine of pi by 3 is root 3 over 2. Root 3 over 2. And so this one becomes root 2 over 6. And then this root 2 times root 3 means root 6. That's minus root 6 over 6. So it becomes root 2 minus root 6 all over 6. That is it. And see, question said exact value right here. Exact. So I believe the answer like that. Or exact. Let's check the calculator if this is correct. Let's see what the calculator would give us. That's what the calculator would give us. Let me see. Let's see what the calculator would give. Let's see. So let's see what we will get. So same costs. I'll put a calculator and read answer first. So we're doing the costs of 7 pi by 12, right? 7 pi by 12, right? Fraction. 7 pi over 12. All right, let's put that on form of the plan. There you go. See there? The answer right there, so. The answer right there. Answer is right here. Answer right there, so. That's what we got, right? Root 2 minus root 6 over 4 here. Root 2 and root 6 over 4. Inside of here. Okay. Very good at that.
Yes,
Yes,
sir.
sir.
I think we're done. I think we're done. Done. This paper is it done. Oh, it's gonna working on. Let's see. I think I could be actually here. Yeah, over here. Yep, we stand on. Oh, no, not on here. We have a proof. We have this proof to do. And this should be there now. But the thing is, this is the same as one of our cost data. I want to work it still, right? So that they're telling us to prove 1 over sec is 1 over cos plus tan theta is 1 minus sin theta over cos theta. All right, so I want to prove this instead because sec is not on the ADMAT syllabus, all right? Let's go. Right here. All right, let's do it right here. Again, we're going to start the left side and work towards it in the right side. All right, so what am I going to do? All right, somebody trying to get this in it. Keep an eye on what you're trying to get. First thing I want to do is write this as sign of a cos. So I'm going to say left side equal to, this is the left side, 1 over cos theta plus sin theta over cos theta. That's what I'm doing here. Then because these have the same denominator, I can consolidate and write this as 1 over 1 plus sin theta over cos theta. So I can invert and multiply this. Or I can know that this terms I can come to the top. All right, so I can write this, or I can look at it this way. Multiply the numerator by cos theta and multiply the denominator by cos theta. This one cancels that one. The end result is this. Cos theta over 1 plus sin theta. But the thing is, this answer has a 1 minus sin theta on the numerator. I put it 2 ways in. I can multiply numerator and denominator of this one by the 1 minus sine. It's one way. Or I can also recognize that the answer has a cos theta on the denominator. So I can multiply the numerator on this and denominator of this one by cos theta as well to get the cos theta that we want under here. Anyway, I choose, we're going to end up with the correct answer in the end. All right, so let's go. I'm using that method. I'm going to multiply the numerator and denominator by cos theta again because the answer is a cos theta in the denominator here. I'm going to multiply this by a cos theta, multiply numerator by a cos theta again. So we'll do that again. So this cos theta times this cos becomes cos squared theta. So I'm now getting cos squared theta over this times this. I'm going to keep them separate. 1 plus sin theta times cos theta. Then this cos squared is same as 1 minus sin squared. Remember, I know this can be written as a factor of 2 squared in sine. 1 minus sine and 1 plus sine. More things you know, the better. But this cos squared is the same as 1 minus sin squared theta over 1 plus sine theta times the cos theta. And then this thing, we'll write out the difference of 2 squares. It's going to become 1 minus sine theta times 1 plus sine theta over 1 plus sine theta times the cos theta. So what happens now is that this 1 plus cos theta and this 1 plus cos theta, they cancel each other. And my final result is this over that. So we end up getting final result, which is 1 minus sine theta over cos theta, which is the right hand side. And that is it. Maybe I took 2 minutes. Maybe I'll do it another time. I'll do it a little bit. But I'll do it this sometime. But that is it. That is it. That is it.
All right.
Very good.
Yes, sir.
Yes, sir.
Yes, sir.
All right. Let's end it now then. Since everybody's good. Since everybody's good, let's call it a day. I'm going to send the video in the group right away.
Okay,
And,
sir.
yeah, I'm going to send the video in the group, and you guys can use the video, try to do the questions over. I'm also going to send some people in the group, some work for you to do. The group, all right, is revision time. You should keep practicing the topics that I've already completed. All right, everybody. See you all soon. All right. Bye-bye.
All right.
Bye-bye,
Yes, sir.
everybody. All right, cool. Bye-bye.
Bye, sir.
Bye,
Bye-bye.
sir.
Bye-bye. Bye-bye.
Bye, sir.
Okay, cool.